I wanted to go through one additional friction example with you. And this is going to use free body diagrams a little bit differently than we did in our last example. And we're going to take a look at another way to determine frictional force. In this example, a rightward force is applied to a 6 kilogram object to move it across an object at constant velocity. The object encounters 15 newtons of frictional force. And in this scenario, we're going to try to determine what the coefficient of friction is between the object and the table. So let's go through and look at what we know. We know the mass of the object, that's 6 kilograms. We know that it's moving at a constant velocity. That means the net force on the object is 0 newtons. They also tell us that the force of friction is going to be 15 newtons. This is going to be the force of kinetic friction because it's moving. We know acceleration due to gravity is 9.81 meters per second squared. And what they're trying to find out is what the coefficient of friction is. So now we have frictional force, and we're going to determine coefficient of friction. If we look at a free body diagram of this, it's very similar to our last one. Here we have frictional force going to the left, gravitational force pointing downwards, normal force pointing upwards, and an applied force pointing to the right. Because it's at constant velocity, I know this applied force is going to be 15 newtons. That's not going to come into the problem, but just for informational purposes. What the process is going to be is very similar to this last one. I'm going to determine what my normal force is by setting it equal to gravitational force. And then once I determine what the normal force is, I'll use the equation force of friction is equal to my coefficient of friction times normal force. I already know what my force of friction is. Once I know what my normal force is, I'll be able to find what my coefficient of friction is. Let's go ahead and do that. So we're going to determine what the weight of the object is. And it's going to be the mass of the object, 6 kilograms, multiplied by 9.81 meters per second squared. And that's going to tell us that the normal force acting on this object is going to be 59 newtons. So that's how much weight is pushing into the table, and this is how much the table is going to be pushing onto the object. So now I know that I have a 59 newton object that has a normal force acting on it of 59 newtons. I'm ready to find what my coefficient of friction is. I know my force of friction, I know my normal force. Force of friction is 15 newtons, and my normal force is 59 newtons. And if I divide 59 newtons by both sides, I get 0.25, and that is my coefficient of friction.